Good evening, everyone. Welcome to the last minute revision to score for tomorrow's IBDP physics exam. If someone wants to score still a grade 3 in SL and grade 4 in SL, I think I given some tips in this video, so you can have a look at it. So the most important topics that I would like to state are something like this in Unit A, Unit B, Unit C. I have mentioned these topics. Okay, so if you just look into these topics, whether you are a HL or an SL student, I think it is sufficient for you to pass the exam. I cannot say you can or you will be able to score it. Okay, note that the HL portions, most of the HL portions, or maybe none of the HL portions are being included over here, but still this will help an SL student, HL student also to pass the examination if you just go through these topics. I have not put the camera on because my camera is not working, but anyway, let me continue with this. Right, so as we had discussed in the last time about the type of topics or the topics that are interest are required to pass and what is the minimum amount of marks that you require. These are the minimum amount of marks that you require over here, and I had already emphasized that you should and must definitely get this one, that is the data analysis. Out of 20, you should definitely get around 12 marks, and that only will increase your marks to get an what to call a pass band of 4 or maybe a 3. Okay, if you get something lesser over here, then this strategy will not help you out. So therefore, see to it that you get maximum marks over here. So this will really help you out. Okay, now let us see how much my strategy will work out. Let us begin with this. The first one is about units uncertainties. Let me just tell you only the briefs. Okay, so where students do make a mistake and how do you overcome them, or what is important, what is the concept tells you over here. The first one is about unit uncertainties and vectors. In units, okay, these 4 units becomes very important to understand, so you can do the rest of them much more easier. First one is, length, mass, time are the fundamental units. That is, your length is measured, I'll write like this. Length is measured in meters, mass in kgs, and time in seconds. These are the very important ones. Most of the questions that we deal with will have only within this, and sometimes the temperature, which is also a fundamental unit, will be Kelvin, and current is your ampere. The rest of them we generally don't ask over here. So towards it, let us say if I ask you something to find out the power. For power, what is the unit? Then you should immediately understand that power is nothing but work done divided by time. Okay, and if I ask you what is kinetic energy, what is nuclear energy, and various types of energy, any type of energy, usually if I say if it is something like magnetic energy, okay, and you do not know what is the formula, but there are 4 options and you need to solve that. The first thing that you need to know is that, so the energy is of the form of magnetic, so therefore somewhere the units of energy should be joules over here. When you say joules, then immediately you should get to know that the work done also has the same unit. So therefore, this should be force into displacement. It should now be, what is force? Force is mass into acceleration multiplied by displacement over here. Mass into acceleration is kg meter per second square, and this is displacement. Displacement is nothing but meters. So it's better I'll write this as d over here, otherwise you'll get confused with seconds. So d over here into meter, which should now be kg meter square per second square. Is how you can understand this. Similarly, one more unit which people generally ask is about luminosity. So luminosity in astrophysics is nothing but power divided by area. The another term that we use over here is nothing but intensity. So therefore, now whenever the question is about find the units for luminosity or for intensity, the first thing that you need to do is, what is power? Power is nothing but work done by time or energy by time, right? You can substitute that divided by area. What is area? Area is given as meter multiplied by meter. How do I get this? Length into breadth. In all these cases, what did I do? Whatever could be the type of question, whichever could be the domain that I am asking over here. So what I need to do is, I just need to look at the fundamental way of defining the parameter. If I do that, then automatically I get the answer, right? So therefore, this is the way how you can understand the units. The next one, as we have seen here, is uncertainties. Uncertainty is the type of questions that you get is propagation of uncertainty. Propagation of uncertainty. What do you mean by propagation of uncertainty? Let us say, for example, if I say the uncertainty in x is equal to 3%, then what is the uncertainty in x cube? Okay, when I ask this question, then what you can do is you can just say 3 times delta x by x, right? So this is nothing but x to the power of m means this should be equal to m times delta x by x. And when I say it is 3%, what does it tell you? This tells you about delta x by x multiplied by 100 over here. So as a result of it, okay, so you remove this percentage over here. So then what you can do, you can find out the fractional uncertainty, which is delta x by x is equal to 3 by 100, which is 0.03. Okay, this is how you can find out the uncertainty. Right. So the next one is about vectors. Vectors. In vectors, what do we have? In vectors, what do we have? In vectors, for example, you have three types of questions that can be asked. The first one is about addition of vectors. The second one is about resolution of vectors. Then what? Yeah, only these two types you can have. Now let us look at what is addition of vectors. When we take about the addition of vectors, what do we have? If I have one vector A and I have another vector B, then these two vectors can be added. But this is not generally people ask you. They generally ask you something like a vector A is given like this, there is another vector B which is given like this. Now how do you add these two vectors? Usually a vector has a head and as well as a tail over here. So if this is your head and tail, and when you want to add vectors, what you need to do is you need to connect the tail with the head, which means what? Now when you want to add these two, this first I will take one of these vectors. You can take any of the vectors constant, then take the tail here. This tail you join it with the head over here. So join it with the head over here. So therefore this becomes tail and this becomes head over here. And then you see, so this has been done. Now we need to complete the triangle. How do you complete? Draw a line like this over here. So this completes the triangle. And then what happens? Okay, now here you can put two tails joined together, and then here you will have two heads joined together. This will define how do you draw the arrow over here. So as a result of it, you will be able to draw the vectors or the sum of the vectors. So the sum of the vector A plus vector B is vector C, which can be written like this. So this is the way how you can add vectors. Next is about resolution of vector. Very important point. The data analysis paper also had discussed about it. If you have a vector like this and you have x and y axis, you define your x and y axis over here, and then you put the angle theta over here, and then you say the component of this, the weightage of this vector, or maybe you can say the contribution of this vector on the x axis is a cos theta, and along this direction this should be a cos of 90 minus theta, right? Because this angle is 90 minus theta. Many of you thinking that this could be sin theta, but you arrive it like this. Finally, you write this as a sin theta. So that's we have got. So we have finished. Okay. So this is the way how you can resolve the vectors. I'm not doing any problems over here. I'm just basically brushing upon all the concepts that are very important. Then the kinematic parameters, SVTA. Okay, SVTA. Usually we call it as SUVAT equations, SUVAT equations. When do we use this one here? We can use this equation only when the acceleration is equal to a constant. What do you mean by that? When acceleration can be represented by a number, a fraction, or maybe a decimal point, let us say a equal to 3, okay, you can use the equation. A equal to 0.8, you can use the equation. A equal to 2 by 5, you can use the equation. A equal to minus 3.5, you can use the equation. When you should not use the equation, if A is equal to 3 times x, you cannot use it. A is equal to 5 times x by t, you cannot use it. A is equal to something like around minus 2t square, you should not use it, right? So whenever you have a variable over here, you should not use this, because when the value of x is changing, A will also change. So now what are the three equations of motion? Three equations of motion are x equal to, or s is equal to ut plus half at square, v is equal to u plus at, v square equal to u square plus 2as. Okay, so these three equations you can use it only when the acceleration is a constant. So this you should not use it over here. Okay, this is all about SUVAT equations. You should know when you have to use which equation. One important thing that you want to know, okay, most of the questions that we get is about a particle throwing from a cliff. When, what kind of equation, how do you use it over here? So generally, okay, so there are two types of problems. The students face a problem over here. The first one is a particle thrown along a straight line horizontally. You fall like this, and immediately what you do is you consider this to be a half projectile motion, which is incorrect. So why is it incorrect? Because you can use a projectile motion provided that you are throwing from here, it goes like this, falls onto here, such that this coordinate, what is the coordinate for this? 0 comma 0, which means x equal to 0, y equal to 0. And what is this coordinate over here? It has covered a distance x over here, let us say range r. What is the y coordinate? Y, again it has come to y point only, so it is 0 over here. See, this y coordinate should be the same, only then you can use the projectile motion. If this y coordinate is different, you should not use the projectile motion equation, it will not work for you. As for example here, now what is the, how do you consider here? So what you do is, you consider this as your x-axis, this as your x-axis, because when I tell you about x and y coordinate, you should know what is your x and y, right? So this is your x-axis and this should be your y-axis over here. So therefore, now what is the coordinate here? 0 comma 0 here. What is the y coordinate over here? So if I consider this is positive, this should be negative. If the height is h, then this should be equal to minus h comma 0, right? And what is this value here? This could be, let us say this could be x comma minus h here. Now you see, this is 0 here and this is minus h here. So you should not consider this half projectile motion, which is incorrect. Now, how do you solve such problems? When you have such problems over here, what you do? A particle starts from here, it has been hitting, so it comes over here and falls here. The horizontal velocity does not change, and thus you can say this distance x is equal to ux into t. Remember always, whenever there is a projectile motion and there is no air resistance, this equation is always applicable. Okay. The next one. Now, a particle has an x velocity which is given by ux. See, this is the way how it has been resolved. This resolution which I told you is applicable here. This is your u, this is your ux, and this is your uy over here. Now, as a result of this, now you can see this uy. Now, when you drop a particle over here, when you throw a particle like this, your uy velocity is 0, and hence your displacement y, which you measured downward, is equal to uyt plus half ayt square. So what happens is uy becomes 0 and then plus half into what is ay? Ay is minus g multiplied by t square. Now most of the students have a doubt whether this g should be taken positive or negative. Should it be taken positive when it goes upwards? Should it be taken negative when it comes down? No. Okay. The value of g is always taken to be negative. It is never positive. It is never positive anytime. When you throw it upwards also, the gravity is pulling it downward like this. When it is here, gravity is still acting here. When it is here, gravity is still acting here. See, the length of these arrows are same. So always the gravity is always negative. It doesn't change with you. Okay. Then we have seen all this. We have seen the sign notation. Sign notation is very important. Okay. And next, what do we have? Let me go back to the thing here. Then gravity, ST graph, VT graph, and AT graph. Okay. So a graph. So in a graph, you have ST graph, displacement time graph. In a displacement time graph, what do you have? When you have a graph like this over here, what does it tell you? Displacement increases with time. When you have a graph like this, what does it tell you? The displacement is not at all increasing with time, which means what? The particle is at rest over here. The particle is at rest. Here, it's increasing with time. The slope of this graph will give you the velocity of the particle. Okay. Now, let us look at the VT graph. VT graph. Velocity time graph. Here, you might get a graph like this. You might get a graph like this. Here also, you might get a graph like this. Possible. You might get a graph like this, which means what? Displacement can become negative, displacement can become positive, can be positive, can be negative, can become zero, anything can it be. But what graph is not possible here? This graph is not possible. See, until here it's possible, until here it's possible. Displacement time graph, until here it is possible. But this part which is curving inside is not possible. Why? Because you see the time is increasing here. Here the time when it goes over here, it can go like this, nothing wrong. But here you see time is decreasing over here. So therefore, this is not possible. Okay. In a similar way, VT graph, you see it's increasing, remains a constant, decreasing, then becomes a constant, and once again increases like this. So what does this tell you? This tells you there is an acceleration here, and here the acceleration becomes 0, but the object is still moving with the same velocity. Here the acceleration is reducing, and when it comes here, what does it tell you? That means the velocity is equal to 0. Okay, velocity is equal to 0, but there is a deceleration, there is an acceleration in the negative direction. Okay, and then you see here acceleration velocity keeps on increasing. That means the acceleration is a constant, and when it comes here, it once again takes an U-turn. Where does the particle take a U-turn? The particle takes a U-turn. Okay, the particle takes a U-turn only when V is negative. Very, very, very important point. When V is negative. So for example, in this case, particle starts at point O. This is the point O. Then the velocity keeps on increasing, going in a straight line. Velocity keeps on increasing, goes to point A, and here velocity is constant. Velocity is constant. That means this is point A and this is point B. Point B velocity is constant. Then after that, velocity is reducing. That doesn't mean it's returning back. Okay, velocity is reducing, still going in the same straight line. And after that, when it comes to this point, velocity is equal to 0. Which means what? It comes to the point C, then it stops here. And the velocity becomes negative. That means what? Here it takes a U-turn over here. Okay, now if you ask me what is the distance traveled from O to C, what do? You find out the area under the curve here, right? You find out the area under the curve from O to C, and after that, now if suppose if I find this area, what will you get this? This area you will get positive displacement S1, this area you will get positive displacement S2. If suppose if these two areas are equal, it means what? This particle started from here, point O, went to point C, and again returned back and reached the point O here. Okay, when it reaches the point O, then these two areas would be equal. This is what you can understand from VT graph. Okay, then you have VT graph, and then you will have FT graph. FT graph. Before we go to FT graph, let us understand VT graph. What all can we get from here? Slope will give you acceleration, and then straight line parallel to time axis will give you constant velocity. Area will give you displacement. But if I consider this area as S1, this area as S2, okay, and then this displacement would be S1 minus S2, because I need to take the signs. But if I take the same area and I take S1 plus S2, which means what? I am considering negative area to be positive area, then I get this as distance. Okay, and then so we have seen, okay, all the entire kinematics. Then comes your free body diagrams, right? Momentum and collisions. Okay, so before the time is a FT graph. In FT graph, what do you have? You might get an equation like this. You might get a curve like this over here. You might get a curve like this over here. Okay, so here slope has no meaning, straight line has no meaning, but what is meaningful is this area. What does this area tells you? So F into delta T, or F into T, F into T over here. Now you see this is it's not just for force multiplied by time, because force is changing over here. So you should not take like this. Let us say for example it is like this over here, a triangle like this. Then what do? I will find out what is this area of the triangle, and then I will find out this one, maybe a trapezoid, and thereby I calculate the total area. This will give me the change in the momentum. I tell you what is the change in momentum. What is the momentum at this point? P final. What is the momentum at this point? P initial. Then we'll take these values for you. Okay. So this is what you can call the change in momentum. Using an FT graph, you can find in change in momentum. If you have an AT graph instead of an FT graph, what do you get over here? See, what is AT graph? AT graph is nothing but, see, this I can write F equal to M into A. Okay. So therefore, if it is M into A, then A would be F by M. M is a scalar over here. So therefore, now what do we get? A to E. So if FT graph gives you delta P, okay, let me write down. Area of this gives you delta P. Then AT graph is nothing but, this should be divided by M over here. Okay. In that case, I divided by M. Area by M. This will give me delta V over here. If I divide this by M, I'll get delta V. The area graph, the AT graph will give you the area under the area, AT graph will give you delta V. Okay, let us move on to the next one. So we have seen almost kinematics. The next is about COM and collisions. What is called COM? Conservation of momentum. When do we use? When no external force acts. This could be an MCQ question. When no external force acts, then your COM is valid. Which means the COM is valid in elastic collision, elastic, and also in inelastic. In both of them, this has been valid. Okay. So towards it. Now let us see what is an elastic collision. Elastic collision is one when energy is conserved. What is inelastic collision? Energy is not conserved. This is what it is. Okay. And now what we have, let us say for example, I have an object of mass M. I have an object of mass, another mass M. Now let us say this is at rest. Okay, this is at rest, and this is moving with a velocity u. And after hitting these two, then both of them join together and start moving. What kind of collision is this? This is an inelastic collision. Inelastic collision. Let us understand how do I write the COM for this. So it tells you, the definition tells you momentum before collision. Sum of the momenta before collision is equal to sum of the momenta after collision. This is what is the definition. Okay, so sum of the momenta before collision, what is the value? So here this has a momenta mu. What is the momentum of this? It was the rest. Okay, let me write this momentum is m into what is the velocity? 0. Because m into 0 should now be equal to what is the momentum of this one? Both of them have joined together 2m multiplied by this. Both of them are moving with the same velocity with the velocity v. So therefore you have mu should be equal to 2mv, v should be equal to u by 2. This is nothing but the momentum after collision, the velocity. So the purpose of doing the COM is to find out what is the unknown velocity v. Okay, we have done this. Okay, so in a similar way you can apply it for any type of collisions. Okay, the next is about FBD. What is FBD? Free body diagram. How do you arrive at free body diagram? Okay, to say I have an object like this, okay, and this is now placed on a table and this is moving like this. Why should it move? It moves because you applied a force. Now when you apply a force, it means what? Force is equal to mass into acceleration. That means the object should definitely get accelerated. It means velocity should increase. So how do you write the acceleration? You write the acceleration like this. Then what you need to do is, first thing is that when an object is moving with an acceleration, indicate an arrow, put an A here. And then what forces will act? mg is acting downward. Then n is acting like this over here. Then is there any other force acting over here? There is no other force, or maybe there is a friction. Let me say there is a friction here, friction over here. So therefore now how do you write this one here? So if you ask me this question, you can now say this n is equal to mg, and then you can also say that this is, now when you say there is a frictional force acting over here, then what will happen to the object? Object's acceleration will start reducing, right? Velocity will start reducing, acceleration may remain a constant, velocity will reduce, okay, and as a result of it, after some time this will come to a stop, right? So you can now say this frictional force is equal to m into a. I can write this because when acceleration is known, I can multiply by this and you can get the answer. And since frictional force is like this, acceleration is like this over here, okay, you can always argue, you can put like this over here. Then what we have is, now you saw n equal to mg, we know that frictional force is equal to mu times n. Okay, always remember you are going to use this whenever there is a sliding, and thus you can now write this to be equal to mu times mg, and now you take this value and substitute here. When you do that, what do you get? You get m into a is equal to mu times mg, or a is equal to mu times t. So you find out the magnitude of the acceleration, right? You can use this one. And if this is constant, see mu is constant, g is constant, definitely acceleration will be constant, or this will be a deceleration because, okay, this was the only force and it tries to pull it in the opposite direction to that of the force, and as a result of it, it will be deceleration. We generally write sign as minus mu times g, and as a result of it, okay, when this is constant, you can always use your equations of motion. This can be applied in any direction. So FBD consists of mainly three parts. The first part is take up one object at a time and write all the forces acting on it. The first thing, okay, by arrows, okay. And the second part of it is that sum up and get the resultant equal to 0 along the axis, which means what? For example, if I take here, this is n upwards, mg is downwards. See, if this is positive, this should be negative. I write n minus mg. So I have taken the resultant, and then what I do? I put this is equal to 0, right? This is one way. And similarly, if I take this one here, ff is like this over here, a is like this. Since this is positive, I'll write ma. This is negative, minus frictional force is equal to 0. Okay, this is the second step. Okay, and then what's the third step? Solve to get force equations. That's it. See, the purpose of every FBD is only to solve and get the force equation. The end product should always be a force equation. Okay. Next, what all have we done so far? Let me go back to this. You see, we have done momentum collision, COM, FBDs. Finally comes the circular motion. We have not done COE. I tell you COE also. Okay. Next is COE. So what is COE? COE is nothing but conservation of energy. So what do you mean by conservation of energy? Energy is constant. Okay, this is what is called as conservation of energy. For example, mechanical energy is equal to kinetic energy plus potential energy. So this is seen to be a constant. It changes from one place to another place. That is, it changes when kinetic energy can be increasing, potential energy will be decreasing, such that the sum of these two will be a constant. From here only we derive work energy theorem. So what is this work energy theorem? So it tells you that change in potential energy is equal to negative change in kinetic energy. Okay, so this is what you call as work energy theorem. You can also write in one more way, work done by an object is equal to either change in potential energy or maybe change in kinetic energy. Okay, you can write like this also. Okay, so this is a consequence of using the conservation of energy. Then what is the last part that we have? Last part that we have is circular motion, right? Okay, one unit will finish up. Now I'll make this as a video and upload it, and maybe in the night I'll do the rest of them. Okay, let's see. So circular motion. In circular motion, what is circular motion? Circular motion is nothing but an object which moves in a circle. It can be a vertical circle or it can be a horizontal circle. Now what is the difference between these two? Whenever a particle is moving in a circular motion, whether it is horizontal or vertical, always remember the driving force should be equal to mv square divided by r, where m is the mass of the particle, v is the speed of the particle, and r is the radius of the particle. Now, if that is the case, now you see here, okay, let us say for example, I take a string, I take a mass over here, and then I rotate it like this over here. When I rotate like this, now why should the object rotate? It's a driving force. Okay, first thing what you need to do is put mv square by r. First you write this because known to you. Okay, where r is the radius, m is the mass of the stone, v is the velocity of the stone, or speed of the stone. And fd, what is fd? Why should the stone return or move? Because there is a tension acting over here. So I will write tension equal to mv square by r. Okay, now let us say there are several cases where you read circular motion. One is something like this. The second one which you have read circular motion is, let us say for example, it's a horizontal circular motion, horizontal like this. But this time the string is not kept here, but instead, sorry, I made a mistake here. First let us learn horizontal, then I'll come back to vertical. Okay, let us say horizontal motion. So therefore, this is the point over here. This is the tension over here. So I can now write tension is equal to mv square by r at every point. So what is happening over here? Tension every time is being pulled inside, while this is called as a centripetal force because acting towards the center. If I take a vertical circular motion will be different from a horizontal circular motion. Now what happens? This is the particle here, this is a thread over here, this is your tension over here. Now what are the forces acting on the particle? Tension is acting like this, mg is acting like this. Okay, that's what I told you. This is incorrect. Okay, tension is acting upwards, mg is acting downwards. Okay, and then so the sum of these two forces is not equal to 0, which should be equal to mv square by r. Okay, so earlier in FBT we took this will be equal to 0. Now I am not going to take it 0 because it's moving in a circular path. Thus I can say T minus mg is equal to mv square by r. So I can put this as a at this point over here, and I can now write Ta is equal to mg plus mva square divided by r. Okay, at this point the velocity is seen to be va. Now if I ask you what is the tension at this point, will the tension remain the same at every point? Tension will not be the same. Here it is Ta. If I take here, tension will be acting like this, mg is acting like this, mg will not come over here. I can now write tension B is equal to mvb square by r. This velocity is also not same. If I consider this point and I ask you what is the tension here, let me call this tension to be Tc. Then I can say Tc is acting downwards, mg is also acting downwards, mass weight of the stone, mg should now be equal to mvc square divided by r, or Tc should be equal to mvc square by r minus mg, right? And if I ask you what is the Td here, I can say Td is equal to mvd square divided by r. But this Vd and this Vb, right? Here it is Vb will be same. So I can now say tension D is equal to tension P. You can say like this. Okay, but now if you want to find out how do you relate this VB to this velocity here, what you can do is you can consider it like this. Let me take up a new slide. Okay, this is a circular motion, this is a point A, this is point B, and I want to find how you relate this VB to VA. If I want this answer, then what I do is I can now say what is the height here. Height is R. I can use my energy equations. What is the energy at this point for the particle? Okay, let me use this as my origin. This should be half mva square. What is the energy at this point over here? Since it has come upwards over here, I can now say half mvb square plus mg multiplied by r, potential energy. Now these two energies should be equal, right? When I say it's equal, then I can now write half mva square minus half mvb square, r is equal to half mvb square plus mg into r, right? So therefore, I shall send this mgr that side, and thus I will get half mvb square is equal to half mva square minus mg into r, and thus vb square is equal to va square minus 2gr. The same thing can also be done for the point C over here. When you do it for point C, you will get vc square is equal to va square minus 2g multiplied by the total distance, which is 2r, which will now be equal to va square minus 4gr. Okay, so thus we have arrived at all the equations so far which we need to look into for the unity. With this, I would like to stop for now, and maybe in the night I will put across for all the other units also. Please go through it. Okay, and if you have any questions, you can always reply me back in the comment section. I would like to answer you all of them. Thank you.